When installing a disconnect for a hot tub that requires more than one circuit, many electricians opt for a small subpanel to manage the multiple circuits efficiently. The applicable section of the National Electrical Code (NEC) that governs the feeder to the subpanel is Section 680.42. This section specifically addresses the wiring methods and equipment requirements for spas and hot tubs, ensuring safety and compliance with electrical standards. Firstly, it's crucial to understand the scope of Article 680 in the NEC. Article 680 covers electrical installations in and around swimming pools, fountains, and similar locations, including spas and hot tubs. The primary goal is to minimize the risk of electrical shock hazards by establishing stringent guidelines for wiring, bonding, grounding, and equipment placement. Secondly, Section 680.42 focuses on the specific requirements for spas and hot tubs. This section outlines the permissible wiring methods, overcurrent protection, and grounding requirement. It is essential to adhere to these regulations to prevent electrical hazards and ensure the safe operation of the hot tub. The feeder, which supplies power to the subpanel, must comply with the provisions outlined in 680.42. This includes the use of approved wiring methods such as rigid metal conduit, intermediate metal conduit, or liquid-tight flexible metal conduit, depending on the specific installation conditions. The feeder conductors must be sized appropriately to carry the load, and they must be protected by an overcurrent device, such as a circuit breaker or fuse, that is rated in accordance with the conductor ampacity. Thirdly, grounding and bonding are critical aspects of hot tub electrical installations. Section 680.42 mandates that all metal parts of the hot tub, including the equipment grounding conductor, the metal frame, and any metal piping, must be bonded together to form an equipotential plane. This bonding helps to minimize voltage differences and reduce the risk of electrical shock. The equipment grounding conductor must be sized in accordance with NEC Table 250.122, and it must be connected to the grounding electrode system of the building. It is also important to ensure that the hot tub is properly grounded to a grounding electrode, such as a ground rod or ground plate, that is installed in accordance with NEC Section 250.52. This grounding electrode provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent device and to energize the circuit in the event of a ground fault. Furthermore, ground fault circuit interrupter (GFCI) protection is required for all electrical circuits that supply power to the hot tub. GFCIs are designed to detect small amounts of current leakage to ground, and they will trip the circuit breaker or open the circuit if a ground fault is detected. This helps to prevent electrical shock hazards by quickly energizing the circuit before a person can be injured. Section 680.42 also specifies the location requirements for electrical equipment, such as receptacles and switches, that are installed near the hot tub. These devices must be located at least 5 feet horizontally from the inside wall of the hot tub, unless they are protected by a GFCI and are specifically listed for use in wet locations. This helps to prevent accidental contact with electrical equipment while using the hot tub. Now, let's address the question of whether the feeder must comply with 680.25. Section 680.25 applies to feeders that supply power to swimming pools, and it includes requirements for the installation of an equipotential bonding grid. However, Section 680.42 takes precedence over 680.25 for hot tub installations. Therefore, the feeder to the hot tub subpanel must primarily comply with the requirements of 680.42 rather than 680.25. While some of the general requirements in 680.25 may be applicable to hot tub installations, such as the requirements for overcurrent protection and grounding, the specific requirements for equipotential bonding are typically not required for hot tubs. The bonding requirements in 680.42 are sufficient to provide adequate protection against electrical shock hazards. Here is a more detailed explanation of the relevant sections. Firstly, NEC Section 680.42 covers wiring methods, equipotential bonding, and other specific requirements for spas and hot tubs. Secondly, NEC Section 680.25 pertains to feeders for swimming pools, and some requirements might overlap, but 680.42 is more directly applicable to hot tubs. The most critical aspects to consider under 680.42 include: firstly, wiring methods. The feeder must choose appropriate wiring methods such as those suitable for wet locations and protection from physical damage. Secondly, ground fault circuit interrupter GFCI protection. GFCI protection is essential for the feeder circuit to enhance safety. Thirdly, equipotential bonding. Bonding all metallic parts of the hot tub and its vicinity to minimize voltage gradient. Fourthly, overcurrent protection. Proper sizing and protection of the feeder conductors. Fifthly, location and clearances, adhering to required distances between the hot tub and electrical components. In summary, when installing a disconnectum feeder for a hot tub requiring multiple circuits, compliance with NEC Section 680.42 is paramount. Although some general principles from 680.25 may apply, 680.42 provides the most direct and specific guidelines for ensuring a safe and code-compliant installation. Always consult the latest edition of the NEC and local amendments for the most up-to-date requirements.